Hello everyone. Today we are going to analyze this frame using portal frame method. This is a two-story and two-bay frame. In this frame there are two lateral point loads, 40 kN in the joint G and 24 kN in the joint D. Let us see the assumptions in the portal frame method. Point of contraflexure occurs at the middle of all of the members of the frame. For each story of the frame, the interior columns will take twice as much shear force as the exterior columns. We know that the point of contraflexure occurs in the center of every members. So let us name the centers. You can see that I have named all the center of the members. Now we are going to make the analysis in the top story. In the top story, let us take the columns GD, HE and IF. We know that in these columns, the point of contraflexure lies in the center. In the top story, let us separate the frame into two parts. From the center of the columns, let us take the top portion. We know that the shear force in an interior column is twice the shear force in an exterior column. We have only one interior column and we have these exterior columns. Let us keep the shear force as P. We know that in the interior column, the shear force should be twice. So the shear force is 2P. The shear forces in the columns should be represented in the opposite direction of this load. Now let us apply the rule sigma h is equal to 0. P, 2P and P are acting towards the left side, so all of them will be negative. This point load is acting towards the right side, so it will be positive. When we add these three, we will get minus 4p. When we take minus 4p on the other side, it will become positive. Finally, for p, we are getting 10 kilonewton. So, in the exterior columns, the shear force will be 10 kilonewton, and in the interior column, it will be 20 kilonewton. Now, we are going to find the member forces. First, let us take the joint G. In this joint, we have two members, GP and GM. In the point P, we have to find the horizontal force HP and the vertical force VP. In the point M, we have already calculated the horizontal force 10. We have to only find the vertical force VM. Let us apply the rule sigma h is equal to 0 and find HP. This 40 kilonewton is acting towards the right side, so that will be positive. HP and 10 are acting towards the left side, so both of them will be negative. Finally, for HP, we are getting 30 kilonewton. Now, let us take moment about G and find out VP. Let us keep clockwise as positive and anti-clockwise as negative. This force is acting in the clockwise direction, so it will be positive and the distance is 2.5. VP is acting in the anti-clockwise direction, so it will be negative. Length of GH is 4 meter, but we need GP. We know that P is located in the center of GH. So to get GP, we have to divide 4 by 2. So we will get 2. So the distance is 2. Finally, for VP, we are getting 12.5 kilonewton. For all of the forces, we are getting positive values. That means the assumed directions are correct. Now let us take the joint H. In this joint, there are three members HP, HQ, and HN. In the point N, we have already calculated the horizontal force. We have to find the vertical force. In the point Q, we have to find the horizontal force and vertical force. Length of HI is 8 meter. To get length of HQ, we have to divide 8 by 2 so that we will get 4 meter. In the point P, on the left side, we have calculated the vertical force and the horizontal force. On the right side, they will be acting in the opposite directions. Here, the horizontal force is acting towards the left side. So, on the right side, it should be acting towards the right side. Here, the vertical force is acting upwards. So, here it should be acting downwards. Let us apply the rule sigma h is equal to 0 and find HQ. This force is acting towards the right side, so it will be positive. These two forces are acting towards the left side, so both of them will be negative. Finally, for HQ, we are getting 10 kilonewton. Now, let us take moment about H and find VQ. This force is acting in the anti-clockwise direction, so it will be negative and the distance is 2. This force is acting in the anti-clockwise direction, so it will be negative and the distance is 4. This force is acting in the clockwise direction, so it will be positive and the distance is 2.5. Finally, for VQ, we are getting 6.25 kilonewton. When we take moment about H, we should not consider these three forces because these three forces don't have perpendicular distance. Now let us apply the rule sigma V is equal to 0 and find out Vn. 12.5 and Vn are acting downwards, so both of them are negative. 6.25 is acting upwards, so that will be positive. For Vn, we will get negative 6.25. That means the assumed direction is incorrect. We assumed that Vn is acting downwards, but actually it is acting upwards. Now let us take the joint I. Here we have the members IO and IQ. In the point O, we have already calculated the horizontal force. Only we have to find the vertical force. We know that in the point Q on the right side, these two forces will be acting in the opposite directions. Let us apply the rule sigma V is equal to 0 and find out VO. This force is acting downwards, so it will be negative. This force is acting upwards, so it will be positive. Finally, for VO, we are getting 6.25 kilonewton. In the top story, we have finished the analysis. Now we are going to start the analysis in the bottom story. Let us split the frame into two parts. From the center of the columns in the bottom story, let us take the upper part. We know that the interior columns will take 2 times the shear force than the exterior columns. Let us apply the rule sigma h is equal to 0. These three forces are acting towards the left side, so all of them will be negative. These two forces are acting towards the right side, so both of them will be positive. Finally, for P, we are getting 16 kilonewton. So, in the points J and L, we will have 16 kilonewton, and in the point K, we will have 32 kilonewton. Now let us take the joint D. In this joint there are three members dr, dm and dj. In the analysis of top story, above the point M, we have calculated the forces. Below the point, they will be acting in the opposite directions. In the point J, we have calculated the horizontal force. Only we have to find the vertical force. In the point R, we have to find the horizontal and vertical forces. Let us apply the rule sigma h is equal to 0 and find HR. These two forces are acting towards the right side, so both of them will be positive. 16 and HR are acting towards the left side, so both of them are negative. Finally, for HR, we are getting 18 kilonewton. Now, let us take moment about D and find VR. This force is acting in the clockwise direction, so it will be positive and the distance is 2.5. This force is acting in the clockwise direction, so it is also positive and the distance is 1.25. BR is acting in the anti-clockwise direction, so it will be negative and the distance is 2. Finally, for VR, we are getting 22.25 kilonewton. Now, let us apply sigma V is equal to 0 and find out Vj. These two forces are acting upwards, so both of them are positive. Vj is acting downwards, so it will be negative. Finally, for Vj, we are getting 35 kilonewton. Now let us take the joint E. In this joint there are four members EK, ES, ER and EN. Previously above the point N, we have already calculated the horizontal and vertical forces. Below the point N, they will be acting in the opposite directions. Also, on the right of R, these two forces will be acting in the opposite directions. In the point K, we have calculated the horizontal force. We have to only find the vertical force. In the point S, we have to find the horizontal force and vertical force. Let us apply this rule and find H's. 18 and 20 are acting towards the right side, so both of them are positive. 32 and H's are acting towards the left side, so both of them will be negative. Finally, for H's, we are getting 6 kilonewton. Now, let us take moment about E and find Vs. This force is acting in the anti-clockwise direction, so it will be negative and the distance is 2. This force is acting in the clockwise direction, so it will be positive and the distance is 2.5. This force is acting in the clockwise direction, so it will be positive and the distance is 1.25. Vs is acting in the anti-clockwise direction, so it will be negative and the distance is 4. Finally, for Vs, we are getting 11.25 kilonewton. Now let us apply this rule and find Vk. This force and this force are acting downwards, so both of them are negative. This force is acting upwards, so it will be positive, and Vk is acting downwards, so it will be negative. For Vk, we will get minus 17.5 kilonewton. We are getting negative value, that means our assumed direction is incorrect. Actually, Vk is acting upwards. Now let us take the joint F. In this joint there are three members Fs, F4 and Fl. We know that here these two forces will be acting in the opposite directions. Also, here, these two forces will be acting in the opposite directions. In the point L, we have already calculated the horizontal force. Only we have to find the vertical force. Let us apply this rule and find VL. These two forces are acting downwards, so both of them will be negative. VL is acting upwards, so that will be positive. Finally, for VL, we are getting 17.5 kilonewton. So we have analyzed both of the stories. Now let us enter the axial forces. Axial forces are the forces which acts in the axis of the members. In the member GH, we have the axial force 30. In the member HI, we have the axial force 10. In the member GD, we have the axial force 12.5. In the member HE, we have the axial force 6.25. In the member IF, we have the axial force 6.25. Let us enter them. In the member DE, we have the axial force 18. In the member EF, we have the axial force 6. Let us enter them. In the member DA, we have the axial force 35. In the member EB, we have the axial force 17.5. In the member FC, we have the axial force 17.5. Let us enter them. Now let us find the vertical reactions in the fixed ends. Here we have the force upwards, so the reaction in the point A should be acting downwards. Here the force is acting downwards, so RB should be acting upwards. Here also the force is acting downwards, so RC should be acting upwards. Now let us enter the shear forces. From the shear forces, we can find the moments very easily. Shear forces are the forces which acts perpendicularly in the member. For the member GH, it is 12.5. For the member HI, it is 6.25. For the member GD, it is 10. For the member HE, it is 20. For the member IF, it is 10. For the member DE, it is 22.5. For the member EF, it is 11.25. For the member DA, it is 16. For the member EB, it is 32. And for the member FC, it is 16. Let us enter all of them. Now we are going to find the moments. We can easily find the moments using the shear forces. First, let us take the joint G. In this joint, we have the moments MGD and MGH. To find MGD, we have to multiply the shear force 10 with this distance. We know that we have calculated the shear forces in the center of the members. The total distance of GD is 5 meter. So to get this distance, we have to divide 5 by 2. We will get 2.5. So MGD is equal to 10 into 2.5. Now let us see how to find MGH. To find MGH, we have to multiply the shear force 12.5 with the half distance of GH. Length of GH is 4, so the half distance is 4 upon 2. We will get 2. So MGH is equal to 12.5 into 2. Suppose I wanted to find the moment MHI. I have to multiply the force 6.25 with the half of this distance. In the similar way, we can find all of the moments. Alternatively, we can use one formula and find the moments. The formula is WL upon 2. Suppose if I wanted to find MIF, W is 10, L is 5. So 10 into 5 by 2. Suppose if I wanted to find MIH, W is 6.25, L is 8. Using this formula, we can find all of the moments. Now let us see how to find the direction of the movements. Let us take the member GH. This force is acting in the anti-clockwise direction, so the movement MGH will be acting in the opposite direction. So clockwise direction, this force is acting in the anti-clockwise direction, so the movement MHG should be acting in the clockwise direction. Now let us take the member GD. This force is acting in the clockwise direction, so MGD should be acting in the anti-clockwise direction. This force is acting in the clockwise direction, so MDG should be acting in the anti-clockwise direction. In the similar way, we can find the directions of all of the movements. We can also have a shortcut. Along the beams, the movements will be acting in the clockwise direction. Along the columns, the movements will be acting in the anti-clockwise direction. These are the movements with the directions. In the fixed end A, we have found RA and the movement MAB. Let us find the horizontal reaction HA. This force is acting towards the right side, so HA should be acting towards the left side. In the similar way, we can find HB and HC. Here I have made the bending moment diagram for the columns. Here the bending moment diagram for the beams. Here I have made the shear force diagram for the beams. Here for the columns. Now we are going to end this session. Thank you for watching this video.